from the beginning, before I started this build series on the Ed Lamb's Climber, back when I still lived out east and I framed the wing, I had plans on building this as a rubber powered radio control model. I have now added a conversion to where this is now a radio controlled, rubber powered, and also a free flight model. I consider this a conversion. In other words, I'll still be able to fly it as a true free flight, with the exception I can bolt on this radio control system and remove it, so I can fly it either way. This idea of rubber-powered model converted to radio control has been around for some time. This is Ed Lamb's Climber. It's a quite large rubber-powered free flight model. The thinking was build a model big enough to be able to handle the weight of the flight pack. Instead, I had another rubber-powered model on the board. It's actually back on the board. This is an AM radio Bill Brunchy gave me. Interestingly enough, the flight pack for this AM radio setup weighs more than the all-up weight of this model. So that's how I was going to build the Ed Lamb Climber, and that was strictly as a radio controlled rubber powered model. And then I built the Climber and I documented it in my Ed Lamb Climber series of videos, and realized that the value this model has as a free flight model, and I did not want to lose that, but I could not get rid of the idea of it also being radio control. So this has been percolating in my mind for a while, and that's, how do I add radio control to this but not lose it as a true free flight model? And I think I've done that. As you can see from that video, I have radio control on the model, and I can also remove it. Simply take 4 screws out, remove this radio controlled brick off the side of the model, and I can remove these plastic control surfaces. My DT is all intact, so I could fly it as a free flight model, use the dethermalizer, or I could fly it as a radio control, rotor powered radio control model. In that configuration, I could also fly it as a true free flight, just leave the controls at neutral on the climb out, let it go through its flight pattern, climb, cruise, prop fold, and glide. And with the radio on, I can't use my dethermalizer, but I could fly it out of a thermal by spiraling it down with the radio. So 3 options here actually. So let's take a look at how I've configured this, how it works, and how I can remove everything to return it to a true free flight model. Remove the wing so we can get a closer look at this setup. So this is what I'm calling micro brick receiver and servo setup, because that's what the manufacturers call them. Micro brick is a board with receiver and servos built in. So I've built mine on a piece of 30-second plywood. I have a shelf here that the receiver is on. So the receiver and the 2 servos are mounted with double-sided tape. So I had sheeted this entire bay here to mount my timer from my dethermalizer. So I have 4 screws that are holding this on to that 1/8" sheeting in that bay. So simply take 4 screws out and that entire micro brick comes right off the side of the plane. I did not use that AM radio that I mentioned in that video clip because we have better, lighter electronics available today. This entire radio conversion on this plane, including control linkages and control surfaces, weighed less than just the flight pack of that AM setup. So this is a 6-channel DSMX protocol receiver. So I have it bound to my DX9 Spectrum radio. And I got all this stuff from a place called Buzzard Models. No caps or spaces, buzzardmodel.com. But I purchased these off of eBay. I've done it both ways, directly off their website or off eBay. It's just whatever's more convenient. Sometimes you get free shipping on eBay. So here's a screenshot of the 6-channel receiver. And I got these digital servos also from Buzzard Models. And here's a screenshot for these 2 servos. So this gives me the dependability of the DSMX protocol, and then these digital servos are smaller, lighter, faster, stronger. They repeat better than that old AM radio. I've located the radio components on this plane so that when I put them on or take them off the plane, it won't alter my center of gravity. So this micro brick and this battery each weigh 1/2 ounce. So my medium center of gravity point, 70% back from the leading edge, is right in line with the back edge of this sheeted bay. So that's why I have the micro brick mounted just in front of it on this side, and I have the battery mounted on the other side just behind it. I have the battery on that side to give me lateral balance. I don't have all the weight on one side of the plane. These numbers here are simply where I locate the shim that's glued underneath my wing to give me those center of gravity points. I have 65, 70, and 70%. So the middle point is right here. Here's the battery for this system. It's a 850 milliamp hour lithium ion battery. You can get them all over the place on eBay. So that's velcroed on to this 30-second plywood plate, which will stay on the plane. It's glued to these two cross braces. I did not have sheeting on this side, and I didn't want to run screws into these cross braces on the fuselage, weaken them. So that is one concession, and it's not much. That 30-second plywood plate will stay on the plane if I remove the radio control. Here's the fun one, these control linkages. I'm taking this idea from the really modern lightweight discus launch gliders. It's a system I think they call a pull spring system. So it's just a piece of the braided fishing line, the same braided line that I use for my dethermalizer, and it only pulls in one direction, and it has a spring that operates in the other direction. So that's even lighter than carbon fiber push rods. Here's a really cool, simple idea I came up with to attach the braided line to the servo arm and be able to adjust my control surfaces. This is a piece of 20 thou wire with a Z-bend going through the servo arm, and I have a loop, and then it's about 1 inch long, enough to give me some adjustment. So I ran the braided line through this loop twice to snub it around that loop, and then I tied a uni-knot around this 20 thou wire and the braided line. So between it being snubbed around this loop and this knot tightened down, it doesn't slip. It holds against the spring tension that I have in the on the control surfaces. So just slide it up or down to zero out your control surfaces, and then of course you still have your digital trims in the radio. I made my control surfaces out of plastic. There was no way I was going to cut out control surfaces in this plane and lose the integrity of the original design. So I have plastic control surfaces off the back edge of the rudder and the stabilizer. And I made those plastic control surfaces out of a case for trading cards. It's my man Wayne Gretzky right there. So not only did I maintain the integrity of the design, these control surfaces will be pretty much invisible in the air. For the hinges, I used a traditional flexible hinge material. Cut thin strips off of it. This is 10 thou thick. So traditionally there's a tool that has a hook on it, and you would cut your slots, and you would actually cut the boss out and slide the hinges in and super glue them. I took a different approach. I made up this tool. It's from 10 thou piece of shim stock, just as wide as the hinges were cut, and I have a razor sharp edge up here on this end. So I simply just pushed this into the trailing edges, pulled it back out. So the balsa just shrinks right back to where it was, and I did not glue any of these hinges in. They're just a tight fit. They're pushed in, and the system is a pull spring system. So if anything, the tension on the braided line is going to keep the hinges in. They're not going to come out anyway. It's tight enough fit, they won't, but one direction is from the spring, the other direction is the pull. So even when the control surface, like this rudder, goes this way, there's still tension on pulling the hinges, keeping them engaged into the rudder. These hinges, this material, super glues really well to this plastic, but I also made it a wider area where it's glued and cut it down thinner for the hinges. In addition to that, I didn't trust the super glue these are flexible hinges, so I didn't trust the super glue. I drilled holes and I made stitches with the braided line, soaked those with super glue. So I have a mechanical restraint on these hinges in addition to them being super glued on. I made 30-second plywood control horns, cut slots into the plastic control surface, super glued them in. Here's the piece of music wire that's creating the spring tension. It's a 12th out piece of wire. I play around with different diameter wire until I got the tension I wanted. And the way this works is this wire is bent this way and this way originally. So I have it restrained under these stitches for the hinge, and 2 more stitches here to keep it in line with the control surface. And then I unwound this end here, put on this side of the rudder, and that torsional tension in that piece of music wire causes it to spring this way. I got the idea for using this spring for tension on a control surface from Joshua Finn of J&H Aerospace. So he had a free flight model that had a sheeted rudder, cut a trim tab out of the sheeted rudder, left the covering on the one side for the hinge, and he had a piece of 10th thou music wire. So he had the bend this way and this way. So he simply pushed one end of the spring into the trim tab, wound it around, pushed the other end into the sheeted rudder, and he had a trim tab with spring tension. And then he had a little bracket with a screw on it that pushed against the rudder. Spring held it against the screw, wind the screw in or out, and he had an adjustable trim tab. So pretty cool idea from Joshua Finn. Lightweight idea to make a very lightweight spring tension in either a trim tab or, in my case, a control surface. So that lets this pull spring system work. Traditionally, you would have a pull-pull, so you have a horn on both sides, and you'd have 2 pieces of braided line. So in this case, lighter weight, pull spring system on the control surface. I have the same setup for the elevator. So the flexible hinges with the stitches, and right here is the spring, goes underneath the stabilizer, causes it to spring up. So there's my torsion spring, and for the 2 halves to connect them, I have this 20th thou piece of wire. So that just has a 90-degree bend, 90-degree bend over here. This control surface is simply hinged onto the stabilizer. This piece of wire connects the 2 halves. So they work together when you work this side. Spring tension and the control horn is on this half. So that's how I set up this RC conversion for the headlamp climber. Very lightweight setup. All the components on here for the RC conversion totals 1.55 ounces. This pull spring system with the digital servos, instant response, very precise control. I'm sure it is because they use them on the high performance discus launch gliders. That spring tension is always there, and you're pulling against your braided line. So very nice smooth control on all the control surfaces. Kind of a pretty fascinating system. So I've added just over 1.5 ounces to a model. The all-up weight of the climber, the airframe with a rubber motor, is around 8.5 ounces. So an RC conversion that only adds 1.5 ounces, 1.55 ounces. I think that's pretty good. There's some more things that radio control will do for this model. One of the big ones is I'll be able to fly it at my RC flying field. I have some big fields around here, and I will fly it as a true free flight model. I mean, there's just no way I'm not going to fly it like that. But I'll be able to fly it out of my RC field, you know, power, climb, cruise, glide, and then thermal with radio control. And any breeze where it's drifting downwind, going to get off a smaller site, you can keep it in a smaller field with radio control. And the other thing it'll do is actually take a little bit of the tension out of the first flights, even test glides. I can test glide it with the radio control, and if something's off, make corrections. So all in all, pretty fascinating addition to the Ed Lamb climber, and I'm really looking forward to getting this out and testing it. Now I'll demonstrate how easy it is to remove the radio control conversion. Four screws. Remove the brick. So that's off. Take the battery off. And lastly, remove the control surfaces. So the rudder, there's the spring, it folds around. You can hear the fit, the press fit into the trailing edge of the balsa. There are the two elevators. That's it. It's converted. The only thing that's not even visible, I have these little slots, 1/8 inch slots cut into the trailing edges for the hinges. One right there, the rudder, there. And that's it. That's all it takes to return the climber to a true traditional free flight model. The original design is intact. Got 4 tiny screw holes for the brick mounts, the Velcro 32nd plywood plate the battery stays on, and then them little slits in the tail surface for the control surfaces. So demonstrate the dethermalizer. Set the timer going. Everything works as it should. So I would call that a very successful RC conversion to a large rubber powered model. And here is the total package to the RC conversion. Have the RC brick, the 4 screws to hold that on the plane, the lithium ion battery, and the control surfaces with the braided line and the connections to the control arms, the little Z bends. That entire package, 1.55 ounces.